This video will discuss the solution to question 40. Please consider the DAC circuit in figure 7. If the amplifier has an output resistance Rout of 1 kΩ and Vref of 1 volt, R1 of 1 kΩ and Rf of 512 ohm, what is the DAC output for the input code of 64? And then 8 possible output voltages are given. Let's start again by filling in the information that has been given to us in the question statement. The reference voltage was given to be 1 volt. The resistance R1 was given to be 1 kΩ. We know that this is a binary DA converter, so every following resistor will have twice the resistance of the previous resistance. So that is 2 kΩ, 4 kΩ and 128 kΩ. The feedback resistor RF was given to be 512 ohms. And in this case we know that the amplifier has an output resistance, so let's add that into here, and that is 1 kΩ. To now investigate what error is caused by this output resistance of the op-amp, we can make the following small sketch. We are going to investigate the error introduced in the output signal by this output resistance, and we are going to do that for an arbitrary input code. So the arbitrary input code will put some of these resistances in parallel with each other, creating an effective resistance of what we will call Rx. We can now use this sketch as a reference for nodal analysis at the inverting input node of this operational amplifier. Note that the potential at this inverting terminal has to be 0 volts because the non-inverting terminal is connected to ground. So nodal analysis will give us the following equation. And if we write this, we get the following. Vout is minus Rf over Rx times Vref. As you can see, the relation between our output voltage, Vout, and the resistance introduced by our input code, Rx, is not dependent at all on this output resistance, Rout. So from that we can conclude that this output resistance Rout does not introduce any error at all. As a result, finding the output voltage for an input code of 64 is incredibly simple because we do not have to account for that output resistance. We already know what the input code is, that is 64, and from question 37 we know that the least significant bit voltage is minus 4 millivolts. So the output voltage for this input code is just 64 times the least significant bit voltage, or 64 times minus 4 millivolts. And that gives us minus 256 millivolts as an output voltage.